So let's look at a little more detail of Newton's first law of motion. First law of motion, the law of inertia, concerns the resistance to change in motion. Sometimes it is considered to be the origin of the idea of momentum. Now, momentum is in fact a quality of motion. One of the ways to look at it is momentum is simply the velocity scaled by the mass or the resistance to change in motion of an object. So if we need to determine the momentum for an object that is moving at 200 meters per second and has a mass of 1 kilogram, the scalar is just mv. So that's going to simply be 1 times 200, where 200, now depending on how you want to write it, it's either kilogram, meter per second, or Newton seconds. A 10 kilogram object moving at 25 meters per second is 10 times 25, which is rather 250 Newton seconds. A 20 kilogram object moving at 20 meters per second is 400 Newton seconds. And finally, a 100 kilogram object moving at 2 meters per second is 200 Newton seconds. If we compare a 1 kilogram mass to a 4 kilogram mass, the amount of inertia is 4 times as much. A half kilogram is half as much. And a 16 is 16 times as much. Newton's second law, which is in the short form F equals ma, really gives us the idea that m over v, or m times v over t, basically says that a force is proportional to a change in motion. Where we have our change. This is what's giving us the change in motion per time, or the acceleration. So a 25-gram bullet fired from a rifle by an unbalanced force of 250 newtons. If the force acts through a distance of 2/3 of a meter, what is the maximum speed? Well, there are a couple of ways we can approach this. We can find the acceleration, or we can look at the change in momentum. So we know the force is equal to 250 newtons, which is either a change in momentum per time, okay, or we can look at the acceleration. Since we know it's a 25-gram bullet, we can say that we have 250 newtons is equal to 25 times 10 to the negative 3 kilograms to give us our acceleration. In this case, we know that our acceleration is 1 times 10 to the 4th meters per second squared. Vf squared minus Vi squared is equal to 2a delta x delta y, whatever distance. We know that our initial speed is 0. Sitting in the chamber, it's not moving. So our final speed is equal to 2 times 1 times 10 to the 4th times the 2/3 of a meter. So we know that Vf squared is equal to 1.34 times 10 to the 4th, and Vf is equal to about 116 meters per second. Now, if we were to use proper significant digits, all of these have 2. So we would actually have about 120 meters per second.